Probability and statistics. Stage 3. Counting techniques. Welcome. The stage 3 of probability and statistics will be explained in this video. In this stage, we will see counting techniques such as tree diagram, fundamental counting principle, circular permutations, combinations, and the binomial theorem. Remember to have your calculator with you to solve the examples. Introduction. Probability is a branch of mathematics that is responsible for the study of phenomena or randomized experiments. A random experiment is one that, if repeated under the same conditions, will not always have the same result. For example, when we throw a coin in the air, we know from experience that it will not always fall head or tails. Lesson number 1. Tree diagram. A tree diagram is a graphical representation that allows you to list all possible results of a random experiment. Example: an ice cream can be purchased in cone or cup, and there are 3 flavors: strawberry, vanilla, or chocolate. How many different ways can you order ice cream? The diagram shows all the possible ways to buy ice cream. In total, you have 6 options. From each of the 2 branches in step 1, 3 new branches are produced in step 2. It is clear that there are 3 times 2 results. Ice cream can be ordered in 6 different ways. Lesson number 2. Fundamental counting principle. The fundamental counting principle is another technique used to list possible outcomes when there are 2 or more characteristics that may vary. If one event can be presented in n1 ways and another can be presented in n2 ways, then the number of ways in which both events can occur in that order is n1 times n2 different ways. This principle can be extended to 3 or more events. Example: the card plate consists of 6 characters. The first 3 are numerals and the last 3 letters of the alphabet. How many different plates can be made if the letters and numbers must not be repeated? First, let's analyze the numerals. The first one can be chosen in 10 different ways, from 0 to 9. For the second one, 9 ways. The remaining 9 numbers, and for the third one, 8 ways. Remember, numbers and letters must not be repeated. The second part of the plate is formed by 3 letters. The first letter can be chosen in 26 different ways. The second one, 25 ways, and the last one, 24 ways. Then multiply these numbers together. 10 times 9 times 8 times 26 times 25 times 24. Thus, the total number of different plates that can be formed is 11,232,000 plates. Lesson number 3. Circular permutation. Factorial is an operation that is sometimes used in counting. Its symbol is an exclamation mark. For any number n, it is written as n factorial and is defined as n factorial is equal to n times n minus 1 times n minus 2 and so on until you get to 1. For example, 4 factorial is equal to 4 times 3 times 2 times 1 equals 24. 6 factorial is equal to 6 times 5 times 4 times 3 times 2 times 1 equals 720. The value of 0 factorial is defined as 0 factorial equals 1. Circular permutation. To find the number of ways in which objects can be placed in a circular arrangement, a first position is chosen, and then the others are placed after another in their position forming a circle, permitting n minus 1 factorial possible placements. Example: How many ways can two married people sit around a circular table if, letter A, it doesn't matter how they are distributed? First, you must know how many people will sit around the table. In this case, two couples. Then, there are four people. Let's apply the circular permutation formula. N minus 1 factorial equals 4 minus 1 factorial. 4 minus 1 is 3, then 3 factorial is equal to 3 times 2 times 1 equals 6. So we have 6 ways you can set 4 people around a circular table. Letter B. There should not be 2 women or 2 men together. The number of arrangements in which we can see the 2 women around the circular table is 2 minus 1 factorial equals 1 factorial equal 1 arrangement. Now, moving all the men into the arrangement without fixing none, we get 2 factorial equals 2 ways to see 2 men for each arrangement. So we have 1 factorial times 2 factorial equals 2 ways you can set 2 married couples around a circular table with no 2 women together or 2 men together. Lesson number 4. Permutations and permutation with repetition. Permutation is a grouping of a certain number of objects in a certain order that are characterized by including all the elements of a set, not repeating the elements of the set, respecting the order A, B, and B, A are considered different groups. If the set of n elements will form groups of R's order elements, where R is less than n, the total number of permutation is P and R, and reads the number of permutations of n elements taken R at a time is given by the expression n factorial over n minus R factorial. Example: how many different ways can a president, vice president, secretary, and treasurer be selected from a group of 12 people? As you can see, the order actually matters. That's why it's a permutation problem, because the order makes a difference. So, we need to apply the permutation formula. Being n the total number of the elements and R is the number of elements that we will take from the set, in this case n is equal to 12 and R is equal to 4. Then, the number of permutations is 12 factorial over 12 minus 4 factorial equals 12 factorial over 8 factorial equals 11,880. Therefore, the fourth position can be selected in 11,880 ways. Sometimes it is necessary to know the number of permutations of objects where some are equal. In this case, we are referring to permutations with repetition. In a set of n objects, in which n1 are the same, n2 are the same, and so on, the number of permutations is given by the following formula. Example: how many different ways can 10 balls placed in a line if 3 are red, 2 are green, 4 blue, and 1 black? This is an example of permutation with repetition, because we are talking about objects that are equal. In this case, balls of different colors. Consider N1 the number of red balls, N2 the green ones, N3 the blue ones, N4 the black one, and N will be the total number of balls. Then we apply the permutation with repetition formula. So, the number of permutations is equal to 10 factorial over 3 factorial times 2 factorial times 4 factorial times 1 factorial equals 2,600. Thus, the 10 balls can be placed in a row in 12,600 ways. Lesson number 5. Combinations. The combination is an array of objects that can be formed by taking all or part of the elements of a set, regardless of the order in which they are. If the set of n elements are to form different groups of R elements, regardless of the order in which R is less than or equal to n, Then, the total number of combinations is written as C and R, and is read the number of combinations of n elements taken from R at a time is given by the expression n factorial over R factorial times n minus R factorial. Example: in a school there are 9 math teachers, 3 of whom are men and 6 women. How many different ways can a 6-teacher team be formed made up of 4 women and 2 men? Since the team will be made up of women and men, the fundamental counting principle tells to multiply the number of ways to select women by the number of ways to select men. Then, the number of ways to make each of these selections will be a combination, as it doesn't matter the order of men or women in the team. The 2 male teachers can be selected from the combination C32 equals to 3 factorial over 3 factorial times 3 minus 2 factorial equals 3. The 4 female teachers can be selected from the combination C64 equals to 6 factorial over 4 factorial times 6 minus 4 factorial equals 15. Therefore, there will be 3 times 15 equals 45 different ways of forming the team. It is important that you know the difference between permutations and combinations. In permutation, the order that the elements are taken matters and applies in situations such as winning lines, the prices of a raffle, places in a competition, among others. In combination, the order in which the elements are taken does not matter. For example, in a team. Lesson number 6. Binomial Theorem. The binomial theorem is a formula that enables the expansion of a binomial to the n power, where is a possible integer. To deduce the formula, we will review the binomial a plus b, raised to the different powers to detect the pattern that is presented during its expansion. Look at the pattern when applying the theory of combinations. The coefficient of a binomial a plus b raised to the n power are the combinations c and r. Therefore, the binomial theorem is established as follows. The calculation of binomial theorem coefficients can be simplified by the use of the Pascal's triangle, which is an infinite set of integers creating a triangle, expressed by binomial coefficients. Now look at the pattern of the exponents. The pattern occurs during the development. In each term, the exponent of the first variable decreases, and in the second variable, the exponent increases. In addition, the sum of the exponent of a and b in each term is n. Example: consider a couple who plan to have 2 children. Find the possible gender combination that all 2 children can have. If A represents boys, B represents girls, and n the number of children, the following will be A plus B squared. Observe that each term of the binomial theorem expansion represents each of the possibilities. 1a squared, one case with boy, boy. 2ab, two cases with one boy and one girl. 1b squared, one case with girl, girl. In total, we have 1 plus 2 plus 1 equals 4 different combinations of children the couple can have. We have reached the end of stage 3. In this video, we could see the difference between counting techniques. We hope this video helps you to understand the topics of the stage. Remember to turn in your next activities on time. See you!